In this video, we will be discussing about array, operations on array, initialization, memory representation, declaration, insertion, traversal, and deletion. Right. So we will discussing one by one. First of all, why do we need array? Because suppose I take a variable int a is equal to 5, right? This can store only one value at a time and it cannot take multiple values. That's why we need an array, because array has an advantage. I can store many datas in one array. Suppose I have to store roll number of 60 students in one array, I can do that, right? Basic for declaration of 1D array, right? The basic syntax is data type, array name, right? Array name, and inside the bracket I will write size. This means one row having 60 columns, right? Now, in similar manner, I can write a character, I can declare a character array, I can declare a float array, right? Now, all data items should be of same data type, either integer or character or float, and all elements are stored in consecutive locations in which index is generally started from 0. So what does it mean? Basically, when we represent the memory, it can be represented as a long tape, right? And suppose I declare the variable int a is equal to 5, right? And one integer has a size of 4 bytes, right? One integer variable has a size of 4 bytes. These all are bytes, and one byte has size of 8 bits, right? Suppose somewhere here, right, I have stored 5, right, and one integer variable takes 4 bytes, right? So when I zoom this, right, the 5 is stored in binary form, something like this, and the address, right, address is allocated in form of hexadecimal. For convenience, we generally write 100, 101, 102, 103, right? And then we will see what is compile time initialization and runtime initialization. So compile time initialization is declaration of array at the beginning, right? Fixing all the values there, right? If I store more than 5 elements, it will give compile time error because the size is 5. And the drawback of compile time initialization is storage can be wasted. Suppose I take array of size 10 and I stored only 5 elements. So remaining 5 places, it will be null elements. So there is a wastage of storage. Also, the drawback is there might be lack of storage. Suppose I declared array of size 3, but I have to store 5 elements. So I cannot store 5 elements in array of size 3, right? Now, how to access an element? Suppose this is at index 0, this is at index 1, this is at index 2, index 3, index 4, right? Index 4, or I can say size minus 1, right? How to access the element, the location of element? So for accessing the location of element, I will use the formula base address. Base address is the first element's address plus size of data type, that is 4, the multiply the index. Suppose I want to access my element at index 2, right? So here I will multiply by that index, right? So what I will get? Suppose this is at address 100, this is at address 108, this is at address 112. So I will add 100 plus size of data type, that is 4 into index, that is 2. So I will get 108, the element at second index, right? Now this data is accessed with a constant time. So constant time it happened because there I have operated only one plus and one multiplication, right? That's why it is at accessed with a constant time, and time taken will be in order of 1, right? This method of accessing an element is also called as random access method. Now for integer size is 4, for character size is 1, right? So simply if I had taken int c is equal to d, sorry, char is equal to d, so it will take only 1 byte, right? Now how to I will declare an array and enter elements on it. The syntax can be written as declaration of array of size 5, right? And then printf enter the elements, and then for int I equal to 0, I less than equal to size minus 1, right? Less than equal to size minus 1 or less than size and I plus plus, and then a scanf percentage d, and then ampersand, sorry, here I will write scanf d and a of I, right? Now we will discussing about insertion. So I am removing this board and we will be discussing about insertion, right? So suppose I want to insert an array. For that I will first declare my array int a, and then a variable size, right? Then I will write printf enter the size of array. Through a scanf I will take my size from user, ampersand size, right? And then I will ask user to enter the elements of array, right? Scanf percentage d ampersand a of I, right? Sorry, here I will write a for loop I is equal to 0, I less than size and I plus plus, right? And then user will input the array elements one by one. right? And then for representing the array, right, displaying the array, I will write printf elements in array are. I will again run a for loop starting from index 0, I less than size plus plus printf %d /d for a space and a of I, right? And then I will ask user which data he wants to insert. So I will ask user which data you want to insert. Suppose user gives the data in form of integer variable, so I will declare here also a number variable, right? So he will give %d a value %num, and then I will ask user which enter the position on which you want to insert your array, right? So I will, through a scanf, I will take the position, right, %. Suppose a variable I declare as position, right? So here position, right? And then I will run a for loop for now. Suppose this is my array. Suppose this is my array. Index 0, 1, 2, 3. At position 3 or index 2, it means position is something and index will be position -1. Its size is 4, but the index at the last element is size -1, right? So what I will do, suppose I want to insert here an element 5, right? So I will increase my size of array by 1 and I will simply shift my all elements to right that are from and at position 2, right? So I will start at I is equal to size -1, right? I greater than equal to that position. This also I have to shift. So position -1 and I decrementing 1 by 1, right? So basically +1 ahead I will store previous data, right? And then at that position I will store that value which I asked from user and I will increase size of array by 1, right? Also, if I want to store element at beginning, right, I will simply run my for loop starting from size -1 and it will go up to this 0 and I will shift all elements 1 ahead and here I will store a value, right? So time complexity in that case will be theta n. Here it will be theta n minus position and here it will be theta n. Suppose I want to store my element at the last. In that case it will be theta 1, the best case, right? Now since my array is unsorted array, for unsorted array, best algorithm for insertion will be simply what I will do. I will go at the last element and then 1 ahead, basically size -1 plus 1, that will be a of size is equal to that the element that is currently available at that position on which I want to store my array, I will store that element there, and then at that position I will store my the value, right? Now here I will write. So this is best case scenario, and the time complexity will be theta 1, right? Now discussing about deletion. This was insertion. Discussing about deletion of an element from array. Right. From taking the elements part will be the same. The above syntax will be different. I will ask my user which element, or basically which the element you want to remove is at which position. Suppose I will take that position through a scanner, right? Ampersand position, and then what I will do, I will run a for loop, right? Suppose this is my array 3 2 1 0. I want, this is index 0 1 2 3. I want to delete this element, right? And then I will shift all elements towards left, right? So I will start my index at, basically position is 2, right? Index is 1, so index will be position minus 1, and the size is 4, right? But the size will be decremented by 1, and also this element I have to shift here, right? So I have to only worry about the size minus 2 index, right? So index less than equal to size minus 2 or less than size minus 1, and I plus plus, right? Then I will simply write a of I is equal to a of I plus 1, right? And then size minus minus, and then if I want to delete the first element, then I will simply run my for loop, and I will shift every element, right? Every element left. For that, time complexity would be theta n. In this case it is theta n minus position, right? And the best case will be when I will delete my element from the last, right? Now the quick and efficient algorithm for deletion will be simply a of position minus 1, right, is equal to a of size minus 1. I will simply take the last element, put it over there, and a of size, simply I will then write size minus minus, right? So this will have the time complexity of theta 1 or order of 1, right? This is best time taken, right? This is for all. We will see in the next video.